Okay, so to understand our chemical reaction, you need to first understand a little bit about electricity. So, in review, electricity is the flow of electrons. Electrons flow because one end is positive and one end is negative. These ends are called the electrodes. The positive end is called the cathode, and the negative end is called the anode. Now, if you remember, as you should, electrons flow through metals, and this is because of the metallic role. So, all of the metal atoms are bonded to all of the electrons. And since of their shape and form, electrons can flow through the metal easily.
Understanding electricity and the flow through metal, we go to electrolytes, which is a solution with ions. When metals are in electrolytes, they tend to ionize. Ionization, plus or minus, ions, making it so that electrical current can flow through the electrolytes.
Okay, so volts represent how hard the electrons are being pushed or pulled, so it's kind of like the amount of potential energy that is in a system, while the current is the amount of energy that is flowing through a circuit. Then we also have oxidation and reduction, which is the type of reaction that is happening with batteries. And this is, the oxidation is the loss of electrons, and the reduction is the gain of electrons.
In this experiment, there are no safety concerns. Just don't get lemon juice or salt water in your eyes, with no hazardous disposal. Lemons, cardboard, galvanized nails, zinc washers, copper wire, pennies, salt, LED lights, electrical tape, voltage tester, spoon, electrical wires. So first we're going to do the lemons. So get your lemons out.
So now you're rolling the lemon to break up the juices. Now you put in your copper wire and your galvanized nails into the lemon. Now you have your lemon. Now you connect the electrical wires to the voltage tester to test how many volts the lemon gets. And here you can see it's getting about 0.58 volts.
So here we have our lemon bag. This is made with a zinc-coated nail, otherwise known as a galvanized nail, and a copper wire. The lemon juice, which acts as an electrolyte, which has ions in it, allows the electricity or the electrical current to flow from the zinc to the copper wire.
So after the creation of your first lemon, you can connect 3 lemons using the positive copper end to the negative zinc end, and finding the voltage of that should be about 3 times what you found in the first lemon. As we can see here, it's about 1.7.
When we hooked up multiple lemons into one circuit, the amount of voltage went up. This is like when you stack batteries in a flashlight. The positive end is connected to the negative end, which then goes through our battery, and then this positive end is connected to the negative end. And so the voltage adds up, and since it's in one circuit, the volts add up to more volts.
As seen here, we see 3 lemons lighting up one red LED, which you need at least 2 volts to light up. Now we are beginning to make a penny battery. In order to do this, begin by first filling up a cup of water. Put salt in it, making it an electrolyte. Mixing this will make it more usable as an electrolyte. Soak the cardboard in the electrolyte so that they can be used as electrolytes in our battery. After they are fully soaked and ready to be used, put them out on a napkin so you can begin the making of your penny battery. We're now going to begin the creation. First, you're going to want to clean the pennies because you never know what's on pennies. This also helps with the electrical conductivity when using the copper of the pennies. Pour the Coke out. Those pennies are clean. Now here are 3 parts to a penny battery. Cardboard, used as the electrolyte, a penny used as the copper, and a zinc washer used as the zinc. Connecting these, you want to put cardboard, penny, zinc, cardboard. And at the end, you're going to want zinc washer on one side and a penny on the other, creating a positive and a negative side. These electrodes are called cathodes and anodes, cathodes being the positive end and anodes being the negative end. You can see the finished penny battery here, with approximately 4 cells.
Here we are using the electrical tape to hold the battery together and make sure that all the pieces of the battery are touching each other.
After putting it together, we go to the phase of testing its capability. To test its capability, you're going to put the positive end on the copper and the negative end on the zinc. This can make the LED light up.
So, the cardboard soaked in electrolytical solution can be used as the electrolyte in this penny battery. We use the cardboard to allow the metals, the penny, copper, and the zinc washer to ionize and allow it to flow through the penny battery and create the current.
And here are the reactions for the ionization of the two metals. So you see here the copper turns into copper 2 plus and 2 electrons. Same with the zinc. So the positive and negative ends of the penny battery are created because if you look at the reactivity series for the likelihood of oxidization, the zinc is much more likely than the copper. If you look at any old regular activity series, that's what you're going to find. So this means that zinc is way more likely to turn into a zinc ion plus 2 electrons. So what that means is that because there's 2 extra electrons hanging out over here, the zinc, which as you can see right here, is going to be negative. Now if you have something negative, as if you follow the laws of all atoms, everything wants to equalize. So the zinc is going to want to lose its electrons, and so it's attracted to the positive end, which is the copper. And the copper is positive because being way down here, the reverse reaction where solid non-ion copper is favored.
Here we connect the penny battery and 4 lemons. This creates 5.13 volts. After combining all of the batteries, we came out with 5.14 volts as maximum.